Welcome, this is Information Service Engineering, lecture number 4, Linked Data Engineering, part 2. In this first part of this lecture, we will start with the so-called linked data principles, which are based on all the technologies that we already know, starting with URIs, with HTTP content negotiation, and of course RDF and RDFS. So, based on all this technology, a huge web of data already exists on the web, and many of these datasets are already open and freely available. So this then forms the so-called linked open data cloud. So this denotes publicly available RDF data in the web, where of course all the data is identified via URIs and it's accessible via HTTP. So this forms linked data, and this is the core of our web of data. And meanwhile, it's huge. There are more than 10,000 data sets, and you only see here the most prominent, the most popular of them. And in these data sets, there are gathered about 150 billion facts, and all these entities you see here, they are linked by more than 800 million links. And of course, this set of data, this linked data, is continuously growing and can be used for many kinds of applications. But first, let's have a look at the traditional data. How do you access your data in a traditional web? Not in the linked data web, not in the semantic web. In the traditional web, if you access a website, then often, of course, this website is produced from a web server. And sometimes, of course, if it's a huge web platform, like for example Wikipedia or any other platform where you have a content management system somewhere in the background, there is a database. And the database provides data which is put into some kind of template, and the web server then delivers exactly that encoded via HTML to the browser. So there are many protocols involved. The web server communicates with the browser via HTTP, and the web server on the other hand communicates also with the database over some other kind of database connector, for example JDBC. So this is the traditional way how data can be accessed, and this can only be accessed via the web server, and there of course is usually a barrier. You cannot directly access the database. Usually there is some software which enables access to the database and delivers the data in a specific format, in a specific way. Usually this kind of access is in form of so-called web APIs. These are application programming interfaces that are provided by the information provider. And of course, with them, you are able to access directly data which is in the database behind the web server. What you can do with it, of course, you can use several APIs to use and combine several databases, and the application you create out of that is then a so-called mashup application, which creates or which uses several or different data somewhere from the web, puts it together and displays it in a new way to enable the user to make use of it. So this is a typical mashup. The only problem that you have here, of course, the API for database number 1 is a different API from the API you use for database number 2, number 3 and number 4. First of all, for each of the databases you need a different API. So if then in the course of time probably some of the data provider changes something, of course, in this application, in this database, then also the API has to be changed. If the API is changed, so probably there is a new parameter or a parameter gets lost or something like that, then also you have to change your application that is making use of exactly that API, which means the traditional way of accessing data in the web and the traditional way to create a mashup application usually is bound to a lot of maintenance work and complexity. So this is an effort. And linked data is a way to cope with that effort and to make these kind of applications much simpler. Because what the traditional web platforms and data providers do is they are building up some kind of walls which shield their application, their data from the other data. So the data is only provided in kind of silos, as we say. And by using a simple and standardized API with linked data based on RDF and the HTTP protocol, this is a simple generic API to access and to publish, on the other hand, structured data in the web, and also to draw connections from one data source to another data source. And by using that, of course, all of these databases could use the very same API and could rather easily be connected. And this is the core idea of linked data, to use exactly this linked data API to enable an effortless or nearly effortless connectivity between the data, and of course the user should be enabled to use this data afterwards. And of course there are guidelines which are summarized in the so-called linked data principles, of which we already know a few, which you have to consider when you want to provide and publish your linked data. So first of all, what you have to do if you want to provide linked data, use URIs to name all the things that you are talking about. But not only URIs, use real HTTP URIs that make use of content negotiation. We have learned about content negotiation in the last part of the lecture. So people are able to look up those names, and for example, that people can get information in a human readable form as well as in a machine readable form. So that can be used from both sides, from the human side as well as from an agent side or a machine side. Then, of course, also in difference to a traditional API, when you look up this URI, provide useful information for machines by using the web standards, so the W3C standards RDF that we have already learned of, or by using Sparkle, which is the query language that enables queries based on RDF databases. We will learn about that later in the lecture. And number 4, of course, what you have to do to make your data useful to others, provide links which connect one data set to another data set, which connect one item in a data set to another item in another data set, so that people are able to discover more things, not only people, but of course also machines. So to summarize the advantages of linked data against traditional APIs, what you are using with linked data is a rather simple and rather generic API for various heterogeneous data sources, which enables a simple reuse as well as data sharing among applications with that. Everything there is based or encoded via RDF, and the nice thing about RDF is open, it's extensible, so you can create new kind of data formats in there, no problem. You create a new property, you create a new class, no big deal. On the other hand then, if you want to access the data, you use HTTP via the standard port 80, which means this is communication which is usually always supported within an organization without taking care of any firewalls. For example, you don't have to use exotic ports or an exotic transport protocol. No deal with that. You use the standard HTTP mechanism over the standard web port. Another plus point is that you use ontologies which enable to make meaningful connections between your data sources and really to understand what these connections mean. Especially, of course, machines are able to deduce what does it mean exactly to follow a specific link or to make use of that. And since the entire model we are talking about, RDFS as well as then the Web Ontology Language OL, we will later talk about that in the lecture, they are based on a model theoretic semantics. So this is a formal semantics which enables us to do reasoning over linked data and enables us to generate new knowledge via an inference mechanism. So we can deduce implicit knowledge and can make it explicit knowledge. So this is a huge advantage of linked data versus the traditional API. So therefore, all of us, we should make use of it. There is an interesting linked open data scheme which is connected with a star ranking schema, so starting with 1 star up to a 5 star. So this is so-called Tim Berners-Lee's 5-star criteria for linked open data. You might know Tim Berners-Lee, who is also the creator of the World Wide Web. You know, in 1989 or in the early 1990s, he was one of the most prominent figures and still is one of the most prominent figures in the World Wide Web community because he created HTTP, he created HTML and the communication between web server and browser, for example. And also he came up with exactly this 5-star criteria for linked open data. So let's have a look on that. First of all, anyway, if you present something with an open license on the web, you get your first star for that. So if it's available on the web, whatever format, but with an open license, it's open data, so therefore you get your first star. Then if it's put in a somehow machine-readable format, so for example, if you are using Microsoft Excel for a table, instead of providing an image scan of a table, then you earn your second star. Your third star you will earn if instead of a proprietary format like Excel, you are using a non-proprietary open format. So for example, for a table you use comma-separated values instead of Excel. Then you get 3 stars. And then if all the data is provided by using the open standards from the W3C like RDFS, Sparkle or also OWL, then you earn your 4th star. And if finally you also provide additional links to other people's data, you will earn your 5 star and then you have a full-flexed 5-star linked open data that you provide on the web and that other people can make use of. So this is a rather nice concept. Okay, so this is the web of linked data. But you might ask, so yeah, it's interesting to have links among these data sets, but where do they come from and what exactly do they mean? According to the meaning that you use usually to connect things on the web, what you are using are so-called linked data vocabularies. So let's have a look at what is a vocabulary. Usually for a person, if you look at a person, it is the set of words within a language that are familiar to exactly that person, or it's all the words known and used by a particular person. On the web, vocabularies, especially on the web of data, vocabularies define the concepts and relationships that are used to describe and represent some area of concern. So exactly vocabularies are, usually encoded here in RDF, some ontological fragments, parts, frameworks that are connecting data. And these vocabularies are used to classify terms that can be used in a particular application, that are used to characterize possible relationships and also to define constraints among these relationships on using those terms. One rather prominent example of vocabulary is here, for example, the Dublin Core vocabulary, which is used for example, documenting bibliographical data, not only on the web, but also for traditional information systems. And they provide lots of interesting properties and entities. So for example, what you can have there in your vocabulary, you have specific terms for what is a title, what is a creator, what is the subject of your publication. Then there is a description, a publisher, a contributor, or a publication date, and so on and so on. So for example, with the help of exactly that vocabulary, you could express that a specific document has a specific title. Let's have a look at that. If we encode it in RDF, first we have to define the prefix for the Dublin Core vocabulary. We call this prefix DCT, and then you see here the URL that is used for exactly that kind of vocabulary. And then we have a document, it's here document XYZ, and we say now this document has the DC terms title, DCT colon title, and then comes of course a string which is the name, the title exactly of that document, and here we also define that it's given in English language. So this is a simple example how vocabularies are used. But for us it's more interesting how arbitrary vocabularies can be created, because also the Dublin Core vocabulary must have some kind of a definition, you know, like RDFS. RDFS also is a language which is able to create or to define a vocabulary. But the point is RDFS is only rather limited. We have seen that RDFS only has a few constructs. For example, we can say something is of type, something, we can say something is a subclass, we can define a property, and that's it. But we cannot put really, let's say, more meaningful, semantically more expressive constraints on exactly these properties and all these terms we define. And to enable that, we have to make use of another language, which is the web ontology language, which can also be expressed based on RDF, and we will learn about OWL in the next part of this lecture.